Okay, so good stuff. Well, welcome everyone. Welcome first and foremost to our brand new webinar platform. For those of you who may not have joined us before, this is obviously a little bit of a different setup. So I'll take just a moment and walk through some of the logistics here. First off, what I see here on the screen is, obviously the different things that we'll be sharing on throughout this webinar, but I've also got a chat window that's up and open as well. So I highly recommend, if you've got some questions as I walk through stuff, feel free to throw them into the chat or kind of keep those going. I'll do my best to keep an eye out for them. We've also got inside of our community Slack, we also have the Loud and Clear channel as well. That's hashtag Loud and Clear inside of the community Slack, and another great place to kind of keep the conversation and stuff going as well. But in any event, it's great to have everyone here, and I'm looking forward to sharing this with you. So with that said, let's go ahead and jump into it and get started. So today's topic is going to focus on a relatively new feature that we've got in LimaCharlie that is known as binary library, or BinLib. Now, some of you may have seen or heard about this before, but I wanted to spend some time walking through exactly what BinLib is, how you can use it, ways that it would be beneficial for organizations, potential use cases, and things like that. And I highly recommend that if you are someone who is utilizing this type of telemetry, that you definitely find a reason to utilize BinLib, because you'd be surprised at just how much power it can add to your organization. Number one. Before I get into it, though, before I get started, I want to talk really quickly about the idea behind something like BinLib, and really something that's kind of at the core, at the genesis of LimaCharlie here, which is we provide observability, we provide visibility into events that occur inside of an environment, whatever it might be: Windows, Linux, Mac, AWS, GCP, Office 365, whatever. However, the nice thing about those types of events and visibility that we provide is, first off, there's nothing hidden from you, the user. Second, it allows us to examine and think about events that we might want to zoom in on a little bit more than others. And that's exactly where the idea of BinLib came about. If you think about the normal types of telemetry that occur on a system of any sorts whatsoever, I'm going to focus in on just a Linux system here that's set up, right? So within a Linux environment, some of the events that we capture and come in are things such as, obviously process events, process starts, process terminations, network connections, so on and so forth. But where this becomes really powerful, and I think where BinLib has really opened a lot of folks' eyes, has been in the ability to zoom in on a particular event and see just how much data we can extract from that particular event, number one. Number two, what more could I do with that data when I've got access to it? What more things could I profile? How else could I use this thing to my advantage? And that's exactly what BinLib came out of. BinLib was this idea of, well, we're already monitoring process execution, right? We're already seeing processes as they start, or as binaries are executed inside of an environment. We're already seeing that occur. We're already seeing that happen. Why not zoom in on just that one particular event? And one of the reasons for this is process execution ends up being the bedrock of detections for a significant amount of malicious activity detection that are out there. EDR still leads the charge, I think, in one of the most useful and sought after sources from a detection perspective. And a lot of it typically has to center around process execution, because let's be clear, in order for me to run code, there's got to be some process in some way, shape, or form. Now, we're not going to go down the road of, process hollowing and in memory and all that kind of stuff. We're not going to get into all that. I want to keep it with the basics that focus on the need for a process in order to execute code inside of an environment or on a particular system. And if I zoom in on that particular event, what types of metadata can I pull out of that? On the surface, a new process event is going to include things like the file path, the command line, the hash, so on and so forth. This data, for all intents and purposes, is useful right here for this process event, and that's it. Because the next time this thing kicks off, almost every single one of these values could be different. However, the thing that's going to remain the same, or at least the thing that I might be interested in a little bit more, is if you call this process multiple sequential times, I want to know, what is the binary that you're actually pulling on? What is the binary that you're executing? What is it that thing does? And this is one of the ideas of where BinLib started, was this capturing of, let's examine the binaries, hence the bin and BinLib, that execute throughout an environment. Now I'm going to go ahead and pick a random date here and see that if I go back in time, and if I go further and further and further back in time, so let's just take this Linux system we've got. Let's hop back to July 4th, 2023 for no reason in particular. I honestly don't know if anything's going to be here for this date. Awesome. Our Linux sensor was not the most responsive during this time. Let's pick October 9th. Let me come a little bit closer to the future. There we go. By the way, nothing wrong with our telemetry stores. Everything wrong with this system not being responsive at that time. However, if I pick up on these certain dates, let's zoom in on new process events, for example. Now, if I look at the data this way, you can all start to see and figure out, that's a lot of SSH activity with these little things kind of dropped in between here. So GCE workload, dash, run parts, so on and so forth. But overall, the process execution of this system looks pretty straightforward. It looks pretty consistent. What I'd be curious to know is if over time this particular file changes, or what happens in between these little blips here. Is it an automated activity? Is it a system initiated thing? Is it a user generated event? And binaries, the history of binaries on there are going to help me kind of pull out some of those details to see what's been executed in this environment during that particular time. Now, the last thing that I'll drop in here about an event like BinLib is not only do we go and analyze and record kind of the initial binary information as they pop up, but the recording of that, meaning BinLib itself, is its own observable telemetry stream. And I like this because it's a stream that is observing and acting upon particular binary events, which I'll talk about in just a moment, but it is also itself an observable stream. So I get the ability to actually kind of almost kind of check it and see what's going on and what's happening, because I can view the events of the BinLib activity as it's taking place. Before we jump into BinLib itself, I want to pick on the particular event that gets fired and the one that we pivot off of. So I spent some time walking through process initiation, process start, process termination, and whatnot. But there is a unique event that gets emitted inside of LimaCharlie, which is called code_identity. Now, for anyone who's writing detections and you're pivoting on process events, code identity is where you're going to flesh out the metadata of some of those particular processes. The other area where BinLib becomes successful is, as you all noticed, as I was looking through the telemetry of some of these systems a little bit earlier here, I've got tons of process events, tons of network events. My code identity ones are going to be a little bit more disparate, a little more few and far between. So for that reason, by zooming in on these events from, again, a BinLib perspective, it allows me to take an event that is not fired as often, zoom in and blow it up, and make another observable stream, because there's really good metadata inside of this here. So code identity is going to be the event that is going to be one of the big generators for the activity inside of BinLib here. And there's a few fields inside of it that we want to be aware of. The biggest one's going to be things like our signature information. This is going to be if the application is signed, if there's any code or certificate details, can we grab those? We've got some different hash values associated with this as well. I'm going to want to capture that metadata because, and I'll talk about this in a little bit, that's important metadata that I'm going to want to search against or use as a way to profile executables inside of my environment. Another one that's going to be critical is going to be something called the import hash, which we'll look at when we get into BinLib and look through those details. Now, I want to drop another quick note in here. Just because code identity events are far and few between does not mean you cannot observe them. You certainly can. And if you wanted to observe code identity events, just drop those into, of course, your event control. There is also an ongoing identity event. This is another one that pivots off of binaries, even if they are not seen for the first time. But I will tell you, it's very, very verbose and duplicative. So now we know what event we're pivoting off of. It's code identity. That's the one that we're going to zoom in on and do more information for. Let's hop over into BinLib and take a look at the BinLib activity that's happening inside of my organization here. So let's pause here. First and foremost, BinLib, or binary library, is cross-platform, Windows, Linux, Mac. meaning it is watching for binary or for code identity events across all 3 operating systems. It's grabbing and looking at the metadata for that information, the data and the metadata, I should say, when that event is fired. What this does is it in turn creates new events that I can use to monitor what's happening from a BinLib perspective. So if I go ahead and I populate this, notice BinLib has a bunch of first seen events dropped in here. And in fact, it's one of the most common events that you'll see inside of BinLib as well, which is first seen. Now, you might be wondering yourself, wait a second, Matt, why are there not a bunch of code identity events in here? I thought that was the one that it pivoted off of. It does. However, when they enter into that BinLib space, it then becomes a first seen event because BinLib is using it to differentiate. Have I seen this thing before? Do I need to grab any information about it? Or is it a file that has already been captured inside of the BinLib database, if you will? And I'll talk about why that's important in just a few moments here. But the other event that's careful to be aware of is acquired. Now, acquired is pretty straightforward. Acquired is going to be, hey, this particular file, the data of this particular file was sucked up and included in BinLib or in the binary library. I'll break this one out here really quick and we'll take a look at the acquired event first. This is one where I've got some really useful details about the file that was captured. Most importantly is going to be, of course, the file path and then the metadata for that particular file. So things like import hash, Microsoft Corporation as the company name, the description, the name, the product version. Quick little pro tip for anyone here. I can tell you right now, this is a 0-byte hash, which we'd have to look into a little bit further because we do have a file size for this right here, but I think this is a 0-byte hash. I'm going to have to remember because I used to have this hash that, yeah, I believe it is. Yeah, it's a 0-sum hash in that case. But nonetheless, that is I shouldn't be able to recognize an MD5 hash just by looking at it, but I do. That's okay. But we capture things like the import hash, signature information, product name, so on and so forth. We do also capture stuff inside of BinLib, such as the SHA-256. We also capture the SID or the sensor ID that this is pulled in as well. Where the acquired events become really useful is it helps me trace back where something was actioned from. Notice this BinLib instance is per organization. Okay, so per organization, all of my acquired and first seen events are going to bubble up into the same BinLib stream. There is no BinLib for Windows, BinLib for Mac, BinLib for Linux that I have separate streams to look through. My differentiator is going to be in some of this metadata here. Let's take a look at the first seen event. Notice how the first seen event is a little bit different, a little less verbose, if you will. This one just simply says, here's the file path, and here's the SHA-256. Was that file first seen or has this thing been observed before? AKA, if this thing has not been seen before, we need to grab it. And that's the other really powerful thing that BinLib is doing in the background is not only is it recognizing that, hey, this is the first time I've seen something, but then it goes and it takes a look to see, have I ever acquired this file or this particular hash before? There's a reason why this is an important thing. Number one, from a deduping perspective, it helps you dedupe and simplify like that part of life, right? We don't want to collect the same file again and again and again and again, and then have multiple duplicates in there because it just makes it really tough. Now, you might be like, well, Matt, hold on. Why would you have so many different files with the same hash on side of a system? Well, one of the keys to that, folks, lies right here, which is how is that file being pushed down and what is it being used for? And let me zoom out to show you exactly kind of the way to tell that. Take a look at my kind of top bar here, and hopefully you can see my mouse tracing over and highlighting these things. Take a look and see at all those different Windows events that pop up. And you'll see that there is a C:/Windows assembly native images, and there's a bunch of Microsoft dot with seemingly random name folders afterwards. Well, folks, this is going to be one of the largest movements of binary files in an organization, especially in a Windows environment, is when there's potentially some sort of an update, some sort of a patch or a push or some other software change that happens and takes place. LimaCharlie is still going to observe those, but it's going to look back and it's going to recognize and say, wait a second, there was an update 2 months ago that included this DLL. Microsoft has not changed that DLL. So all of these subsequent updates and patches, the hash is staying the same. I'm not going to reacquire something that I've already got a copy of. Now, my first scene event is going to capture the different file path for it. But the actual grabbing of the file itself, the deduplication of the hash, is going to occur based on a brand new hash or something we haven't seen before. So just a quick note for any of you out there who are going through and kind of doing analysis on this. When you see, if you take a look at BinLib here, we've got this massive push of binaries from like 10:05 to 10:08 p.m. This is not someone, I mean, it could definitely be someone unzipping, but in this case, it is not some sort of automated or manual activity. It's probably some sort of a patch update or a program install or something like that. So there will be multiple instances on a normal system where you will see just an influx or a massive push of binaries on the system. And again, that's nothing to be alarmed of. That's just normal expected system activity. Another quick note for everyone here, if you zoom in on this one a little bit, you'll notice that I've got Windows and Linux first scene events running alongside right next to each other. And this is really cool because it allows me to see across my environment and know I'm capturing, again, Windows binaries, Linux binaries, and I'm seeing that activity run kind of side by side. So the other thing that's worth noting amongst this here too is, like any telemetry stream in LimaCharlie, not only is this telemetry stream observable, but it's also actionable as well. So if I wanted to write a detection and response rule against BinLib data or something like that, I could certainly say, hey, if any file ever gets observed by BinLib and it's in C:/user/public, for example, let me know what that hash is because I want to do some additional things with that. All right. There's also an opportunity to do that inside of just a normal detection and response rule as well. However, think about how much cleaner I can write detection and response rules if I utilize BinLib. And this is another opportunity for us to think about, well, wait a second, and let me just draw see if I can't maybe come up with some simple detection logic here, right? Folks, this is not going to be a real detection. This is just going to be me kind of drawing up the logic here, right? So let's just call this rule number 1. And this is direct process execution, okay? So in this case here, my event might be new process. I'll zoom in on this just so everyone can see. My event might be new process. And then I'm going to drop in some sort of conditionals. And I know this is not a DNR rule, but follow me through this thought process here. If located in C:/users//public. Well, that's a really good place to start because it's going to alert on process execution inside of that particular path. However, what if I want more? What if I want to take the hash of that particular file or some other metadata and use that to run up against, I don't know, virus total or some other checking source where I can say, hey, is this malicious? Is this thing malicious or not? Of course, I would go the route of saying that anything that shows up in C:/users/public is going to definitely qualify as suspicious. But then the next thing I've got to do is response would be, let's see, grab the hash. And then I'm going to, run the hash against, run the hash against not a directory. I'm going to run it against an API lookup or some sort of thing like that, and then report on the metadata or action based on the metadata. All right. That is how I would put together kind of a direct process executable rule. Again, not perfect syntax, just us brain dumping and walking through this. Well, I could also drop in rule number 2, which is BinLib observation. All right. Now, BinLib observation is already going to have a lot of the details captured inside of it. So in this case, my event might be, and I'll learn how to type eventually, my event might be first scene, as we mentioned before, right? And then file path, let me see here. There we go. File path contains something like users/public or whatever it might be. And my response, well, hold on, there's more metadata inside of it I can already process. Maybe I will take the file hash and compare it to VT from an API perspective or some other API lookup or something like that. And then I've got an opportunity to potentially streamline my response a little bit if I want to, because I'm removing, or I should say, I'm making it a little bit more of a succinct rule set. There's another option, which is when we get into the next feature of BinLib, which is the ability to access the data of that particular file. Because the other thing that BinLib does in the background is not only does it see the files, but it also, or the binaries, but it also acquires the data for those files, hence the acquired event. So the nice thing about that is I now have not only an observation of the binary on the system, I've also got the raw data up in BinLib, which I can then perform searches against or other types of analysis against. So if I go here, let's just say it's a piece of malware or something I want to be aware of, right? Well, in this case here, in my first rule, I also have to drop in a clause to grab the file. So I've got a copy of it on hand. BinLib already takes care of that. We're done. The file's been observed. It's already been captured. Binary file or binary metadata is stored up in binary library. And my response at this point can then be utilize BinLib data for additional actions. And there we go. And again, brain dumping out a detection and response rule, not perfect syntax. But the nice thing is it allows me to have a little bit of a different use case and start to build my rules out a little bit differently, depending on what my final action might end up being. Let's jump into BinLib though and see, we don't really need to get down into the detection and response rules in order to make sense out of this. So over in our extensions, there's going to be the wonderful BinLib or binary library here. And this is going to be the web front end, the web UI for accessing through this particular data. Now, I'm just going to make life easy for us because I want to make sure that we're searching for something that I know is going to be in here. So I'm going to go ahead and look for a first seen event. And I'm going to go pick a file in here that I know will likely have some metadata for us as well, just to demonstrate what's happening here. Only because I don't have a bunch of malware kind of pre-stored on this. I'm going to grab the SHA-256 for this file right here, which is msscntrs.dll. I'm going to say something like MSS centers or something along that line. That's going to be the DLL that I'm interested in to walk through BinLib in the very beginning. So again, scrolling down to BinLib, there's a couple of different features inside of the web UI here that I can use to my advantage. The first is going to be, did this particular hash ever exist inside of the organization? Now, hold on a second. Let's backtrack here. If I'm approaching BinLib from a, has this hash ever been seen? Then I'm likely not starting at the telemetry stream itself. So this allows you to come at this data from two different angles. If I'm going to look at the raw BinLib stream, the raw BinLib telemetry, I'm looking for what are you seeing? What are you observing? What are you gathering? What's already in there? I might pivot a search based on the data that's there. If I approach BinLib from the more public side or the more unaware side, I'm coming to this with predetermined information or predetermined something that I've got from somewhere. It might be an API lookup. It might be a threat intelligence source. It might be a note. It might be a hash that I found on another system somewhere. It might be some other source that says, hey, here's an MD5, a SHA-1 or a SHA-256, and this thing is not good. This particular hash is not good and should not be in your environment. It's malicious. I can approach BinLib from both angles. I know what I know, or I don't know what I don't know. And I can use both as an example to search through. I went to the telemetry stream though and grabbed a hash just to demonstrate how BinLib's really easy to use. I'm just going to go ahead and utilize the very first part of this to drop in there and just check to see, has this particular hash been observed inside of the environment? And let me see here. I think my I think my browser may have thrown a quick loop at me. Here we go. Let's run through that one more time. And if I want to go and check for the hash, there we go. That's the box I was looking for. I'm going to go ahead and hit check hash. And what I did in this case is I went through and I took a SHA-256 that we had pulled out of our BinLib stream. And I went to see, hey, does this thing exist inside of my environment? Has it been seen before? And sure enough, BinLib came back with a really simple, straightforward yes or no. Here are the corresponding hashes for that thing as it's been observed. But we all know this is not really the data that I'm interested in. Or maybe it is. Maybe I want an initial thing. Has this been observed before? So the next request that I might look at doing is I might look at hash metadata to say, has this file been seen? And if it has, what types of metadata do you have about this particular file? Now, note in BinLib, you can do a single hash or multiple hashes. Regardless, I want the metadata for that particular thing. And here we go. Here's all that sweet, sweet metadata that we observed in that event a few minutes ago when we were walking through it. First off, has it been seen in the environment? Yes, there's the hash information. The metadata is the critical part here. What's the import hash? What's Microsoft Corporation, PKM perfmon, Windows search, so on and so forth. I'm getting more insight into what this particular file is just by simply browsing through the metadata of this. I can, of course, also see the other hash values, the size, and the type that it was. Let's go a step further and say that's a DLL of interest or a file of interest to us. We could, if we wanted to, also go and grab the data for that particular file as well. Now, only because we're on recording here, I'm not going to hover over that URL. But what I've got in this case right here is a quick URL available, and it's a very, very ephemeral one. But I've got the ability to go download that particular file or that binary from this location, allowing me to go a step further in my analysis to have a copy of the actual binary if I need it. So in short summary, and we're not done with BinLib, but to summarize where we've got so far, we took a look at the BinLib telemetry stream, which observes binaries, brings that data back, and becomes its own series of events. We also took a look at some basic cursory searching, knowing what a hash might have been ahead of time. Now, of course, we could go obviously multiple steps forward and say, well, what if I have a hash that I don't know about? What if there is a thing that I've received, again, a threat intel report or something along those lines? And I'm going to see if I can't find one really quick. I might even say a huge, huge, huge hat tip to our Intel channel because they're giving me a threat report that will hopefully be readily available here. Let's see if I can't find one that we might get a hash out of. And fingers crossed, fingers crossed. Ooh, we've got some interesting ones here. All right, I'm going to see if I can get a hash out of this one right here. It would be great if we had a hash. There we go. All right, so let's bring this one over. I just went and I grabbed this particular threat report from our Intel channel. Huge props to the folks on our Intel channel. But this is ToddyCat, a piece of malware that came to us from SecureList, or at least was called from SecureList. And they talk about an advanced APT actor that they've disclosed in a previous publication, so on and so forth. But at the very end of this, they go through and they provide, and there's a quick link to get down there as well. They provide a bunch of indicators of compromise. Now, in here, we've got the basic expectations, MD5 hashes. We've also got file paths of where that file might be located, file names of where they might be located as well, domains, URLs, registry keys, mutexes, so on and so forth. The hashes are going to become my first search or my first pivot point. So I'm going to go ahead and grab a copy of this particular hash here. And let's see, copy. There we go. And I don't know if this thing exists or not, but I'm grabbing the first hash for this PCXter binary that was observed as part of this threat campaign. Well, heading back over to LimaCharlie, I'm going to want to say, hey, has this hash ever been observed inside of the environment? And in this case right here, yes, our request was successful, but no, the binary has not been found. So you got to be careful in the way that we interpret this one here. And let me go a step further and drop into the hash metadata, drop this in here one more time and show you, boom, found false. This thing has not been observed inside of my environment. And the really easy way is to just wash, rinse, and repeat through those hashes. I can also drop in a list of hashes if I want. Notice that any of my search queries allow for a list, a new line separated list, or a comma if you want. You can drop multiple hashes in there, and I can just paste one, drop in another, and LimaCharlie will help me find that particular hash if it's inside of the environment. So there's a really quick use case to take kind of threat-related data or IOCs and bring them into the BinLib searching capability. But I have to, and those of you who have done incident response or malware or reverse engineering or any sort of digital forensics or any sort of SOC monitoring, know all I've done so far is just scratch the surface, because hashes are not the things that adversaries or are going to be necessarily the highest sort of, or the highest fidelity of detection inside of my environments. The big reason for that is because hashes can be easily changed. Hashes don't serve as a bulletproof detection mechanism because they can be changed. They can easily be modified. It takes one byte of difference in order to make a hash change. So for that reason, this is where I tend to look at the search options inside BinLib as one of the more powerful options in here. And if I scroll down to our search options, let's talk about why that is. Notice all of those different columns and all those different fields that we saw in an earlier example is something that's going to be of extreme relevance for me and very, very important for me to have. However, some of the other fields in here are the ones where you actually end up catching a lot of adversaries because these are things that they may not change as much. Or these are fields that are going to give me a much higher fidelity search because, again, they're going to be things respective to an application regardless of the hash. Let's walk through a few of these and kind of talk about maybe how that works or what that looks like. I'm going to go ahead and pull up another hash from my BinLib. And I'm doing this one off the camera here just because I'm going to make it quick. But I'm going to go and grab a quick hash from one file on here. I'm going to pick another Microsoft DLL or EXE just because I want to use it as an example to show you how to easily search through this. If I come back and get our hash metadata, I'm going to drop in this SHA-256 that I just grabbed. And you'll see, here we go. Totally random. I picked up on the, this particular binary created by Microsoft anti-malware Windows update stub, I'm guessing, Microsoft malware protection. We've got version information, signature details, so on and so forth. Let's hypothesize for a moment and just say that anything that comes down the line from Microsoft, I'm suspicious of. Well, I don't want to go back through the BinLib telemetry and start searching and scrolling for all the Microsoft related stuff. I'd rather go to that library, to that consolidated source and say, show me everything that has come from Microsoft. So I'm going to go ahead and grab this particular name over here, and we're going to use this searching to our advantage. I'm going to come down here to our search option. And the thing that I'm going to look for, the field that I want to pivot off of, is going to be the company name. I'm going to drop in an equal statement, and I'm going to put Microsoft Corporation in there because I know I've seen it before. Before I click search, let's go ahead and walk through what a few of these fields are. So first off, every single metadata field that you saw listed in BinLib is something that can be searched against. So I can search against size, signature issuer, signature subject, import hash, company name, serial, so on and so forth. I can also drop in different operators. So I could go as one step and say, show me everything from Microsoft, or I could go another step and say, show me everything not from Microsoft. Single out the executables that are not from a trusted provider. I can also drop limits in what I want to search. So again, depending on the quantity that you're expecting to get back or the types of searches that you're running, you might not want to pull back every single binary that has been observed. I might want the first 10. Because it's going to make my search much easier and see if I'm actually, kind of headed in the right direction for things. In this case, because I know my search is going to be pretty verbose, I'm just going to select the top 100. And my search in this case is I'm looking for instances where the company name equals Microsoft Corporation. I should get some results back because I already know that this particular thing is going to work. I already know that this field is going to come back because I've got evidence of this particular search, or I've got evidence of files with this particular metadata already working. And if I go ahead and click on search, looking for a company name of Microsoft Corporation, boom, there we go. So first off, I've got 100 binaries listed here only because this particular search did not run out of examples. And then I've got a bunch of different files here with a bunch of different metadata fields that I can use. And this is a chance for me to use that company name as a pivot to then hop over to BinLib and say, hey, where else have you observed or seen things from this particular company or with this particular description or with this product name or whatever the field might be? The other area where we can kind of amplify and step up our malware searching or malicious file searching capabilities is with this little field right here. So let me just recap. We started our search looking for just basic hash information. Hashing is very valuable, is great for IOCs, but is not 100% reliable for detections because if I'm saying these 10 hashes are not in my environment, I'm not doing much to kind of guarantee that they're not there at all. I can search off of well-known fields like company name or signature details or anything like that. The problem sometimes with those is that they're also easily deletable or changeable. So what's the difference between Microsoft Corporation, Microsoft Corp, Microsoft, or Microsoft Corporation LLC, or whatever the final company designation might be? Well, to Microsoft, the difference might be nothing. To the average person, the difference might be nothing. To my detection and response rule, the difference might be everything. So we wanted to find a way, and this is a concept that's been around for quite a while now, but we wanted to find a way that said, okay, there's all of these things that adversaries can change about their binaries. Is there a maybe a field that we can stand on and have a little bit more confidence around? And the import hash is exactly that. The import hash is called the import hash because it takes a look for binaries. It takes a look at the particular libraries that get loaded when that particular binary runs, gets booted up. And it goes through and it's actually the import address table. It goes through and it hashes the imports that binary is going to bring in. So imagine I've got an executable, and that executable relies on 10 different DLLs in order to do its thing inside of Windows. Okay. Again, a binary that relies on libraries. And when that binary starts up and that process event is observed, it's going to need to load those particular DLLs in. It's going to import those functions. Now, it might import an entire DLL. It might import one function from that DLL. It doesn't matter. The distinction is the things that it's loading, the things that binary is relying on. That's the important field. That's the important thing to be aware of. Primarily because what we've noticed over years has been as malware authors write malware, they don't change some of the inner workings of these binaries as much as you would expect. The file name, arbitrary. The file hash, arbitrary. Company details, signature information, if it's even there, arbitrary, easy to change. But if I'm an adversary, I'm not rewriting, refactoring, restructuring, changing around, and swapping libraries for every single time I write something. Let's say I have a piece of ransomware that I've written, and that piece of ransomware utilizes 5 DLLs. And then I run it, I deploy it, and I notice that there's a typo in the spelling of the file extension or something like that. So I create a new version. Well, that new version is going to have a new name, new company information, potentially even have a different hash. It's going to have a new hash, hint, hint. However, the internal pieces of that, the import table, the import hash, are going to be the same because I'm still looking at the way that I'm importing and bringing those libraries in. And this has actually become a really good differentiator and a really good search term, or I should say a search property, to identify common files around environments. The other area, and let me see if I can't give you an example here. I'm going to grab the import hash of this particular Microsoft executable here. Let me go ahead and grab a copy of this. And I'm going to search on the import hash field to see if I can find any other files that have an import hash similar to this one. And in this case, we have none. Now take a look at how I went from Microsoft Corporation as my first search term to a scaled out set of results down to just one based on that import hash. I'm going to try one more to see if we have any other common denominators, and which I would absolutely love to see here. We're going to run another search. We're going to repeat that one for company name equals, and I'm going to put Microsoft Corporation, just like we had before. Excuse me, we'll run another search. And I'm going to grab the import hash here, this C4150, or say C415987. We'll repeat another search for this one. Again, hopping over, building that search out for the import hash, dropping in an equals, dropping in that particular hash there. And in this case, once again, we've just got a unique file. So what this does is it gives me a chance to identify some unique or potentially shared attributes across executables without having to rely on the stuff that's arbitrarily changed. Now, there's two other powerful features inside of BinLib that I want to make sure we cover today. The second one, or I should say the first that we should talk about, is going to be the concept of tagging. So tagging, if you may have noticed, if I go in here, tagging is another field that I can search against inside of BinLib. Now, tagging is going to be a little bit more user-generated, meaning us, the platform operators, are going to be the ones adding value to executables from a tag perspective. And the tagging is really where you can flex on that binary population. Let's say, hypothetically, I've got BinLib and it's full of a bunch of different binaries. I've got a test environment, a dev environment, I've got production, and I want to start to differentiate between all of them. Tagging would be a really great way to build that out. Okay, this thing has been observed in this location on this system. It is a production executable. This thing's been observed in another location or on a developer workstation. It is a dev. It's a dev workstation. It's a version, an iteration of something. It is not the final product that's out there. What tagging does is it also lets you add threat details and threat information to those particular files. The biggest one I can think of, the most useful type of tagging that you could potentially drop in here would be something along the lines of the MITRE ATT&CK framework. And this is one of my favorite things to think about from a tagging perspective, just a way to, again, utilize tags to kind of help add a little bit more context there. But I'm going to hop over here and we're going to pull up the MITRE ATT&CK framework for bits admin, which is a command line tool that's used to create and manage bits jobs. Now, there's not much inside of this here. It's a relatively straightforward one, but take a look. Bits admin is something that can be used for multiple different MITRE ATT&CK techniques. 1197, 1048. So I've got things like bits jobs, ingress, lateral tool, and exfiltration over an alternative protocol. Folks, these are all values or variables that I might want to know about. Or we could go a step further. And I'm not sure if anyone has seen this one before, but if I hop over here, the other really valuable project is going to be something called LOL-BAS, or living off the land binaries, scripts, and utilities. I should say binary scripts and libraries. And when we say LOL, we mean living off the land. And this is a nod to adversaries who do not bring their own malware into an environment, or may not bring all of their own malware in. They actually utilize tools that are already on the system itself. And here's bits admin again, because bits admin is a tool that is built into the Windows operating system, but adversaries have figured out how to use it maliciously. And what this particular amazing website does is it goes through and it lists, here's this file, here's what it can be used for, here's ways that it can potentially be abused by an adversary. They even tell us what to look for with some sample Sigma rules or IOC details in there. What to look for when this particular thing runs. This is great. I love having all this information. But what happens if an adversary brings in a malicious file, a malicious bits admin? How would I go through and search between the two? BinLib. BinLib is going to capture all those different details for me and allow me to go in and differentiate between what was observed, where it was observed, and how I can use that information to help determine, is this good or is this bad? It might also be a tag that I want to throw on any executable that comes through. Anything that's listed inside of my LOL-BAS here might get a tag of LOL capability or LOL possibility. And what this does is it gives you another thing to pivot on in either your detection and response rules or in your search queries. Now, of course, the most obvious use case for tagging is you go grab a threat report, you take that threat report, look for hashes inside of your environment. If you find one of those hashes, you tag it with that threat actor. You tag it with, okay, this thing has been observed by APT 50, whatever. I'm going to tag it as such that I know that it's associated with that. But I don't want anybody to think of tagging as just something that I've got to use in the event of a bad file. I like to think of tagging as actually something I can use in the event of almost any file that comes through, because I'm going to use tagging to help me differentiate good or bad. Let's talk about detection and response rules. Let's say, again, I've got a detection and response rule that looks for malicious processes or LOL bins being misused by an adversary. Tagging can be a really good way for me to kind of offer a quick double check against that and say, hey, is this the legitimate binary? Yes. Perfect. Now go look through these analysis steps. Hey, is this thing a legitimate binary? No. Perfect. We've now escalated fidelity really quickly. So there's a few different ways that you can start to integrate detection and response rules with BinLib and get some really nice actionable results out of it. The last and final little feature that I'll mention when it comes to BinLib is going to, of course, be, Matt, we talked about if I know a hash. We talked about if I know metadata. We talked about if I know what the import hash might be. We talked about tagging. What if I don't know anything about this malware whatsoever, but someone is telling me I need to go look for blank threat actor or blank capability or whatever it might be? The other capability that we've built into BinLib is YARA scanning. Now, folks, for those of you who may not be familiar with what YARA scanning is or how it works or what it might be, YARA is known as the pattern batching Swiss knife tool for malware researchers, and I'm just going to call it detection engineers as well. And YARA is a capability that, first off, it's built into the LimaCharlie EDR sensor, number one. Number two, it's also a feature set that allows you to identify and classify malware using rules geared towards those particular files, using rules that may help identify key attributes of a particular file here. So walking through a sample rule that they've got here, the most important part, folks, is going to be right here. So inside of this part of the YARA rule, and if you're not familiar with YARA, I highly recommend, you've got homework now, go read up on it. But YARA allows me to declare things that should be inside of a particular file. And those things can be wide and diverse. They can be hex strings. They can be strings with wildcards in them. They can be PE information. They can be metadata about the file. They can be text-based. They can be hex. They can be all sorts of values. And then there's all sorts of logic I can drop in the way that I find them as well. But in this simple example of this YARA rule right here, there's three strings that have been declared, A, B, and C. A and B are both hex strings. C is an ASCII string. And take a look at my condition down here at the bottom. I want you to have one of these three things in order for this rule to be positive, for this rule to trip. Where this becomes critical is, take a look. There's no metadata about these files, meaning there's no signature information, cert details, company information. There's no hashes inside of here. These are behavioral traits or code-based traits of these particular files that I want to use in my search terms. And where this is very useful, where this is very, very useful is I no longer have to focus on search terms or attributes that are going to be static or easily changed. I can now use the behavioral side of things, meaning strings that are always present inside of malware, or key hex strings that represent the malware's encryption algorithm or data storage algorithm or exfiltration or C2 protocol or whatever it might be. I can actually drill into those executables and use YARA rules to help balance that out. By the way, just so everyone here knows, today is October 18th. This coming Friday in our LimaCharlie office hours, we will have a more dive on YARA that I highly recommend checking out. But for right now, my big takeaway here is I want you to know it's another way to classify binaries, another way to classify a separate set of details, separate set of binary details. We bring that into BinLib. Because we go and we capture the data of those binaries as they're observed, that becomes another searchable field for us. And in this case right here, I'm going to go through and I'm going to say, all right, I need to drop in a little bit of a qualifier here, but let's just say I want to look for, or I want to look across those same executables that I was looking at earlier that had Microsoft Corporation as a company name. That's going to be my parameter. That's going to be my initial criteria. Now, some of you may be like, well, Matt, why don't we just select star and search across all of them? The big reason for that is, of course, A, I want to have this search back in a quick time. B, there might be some qualifier I can use to rule out a bunch of files or rule in a bunch of files. So for example, watch this. I could go the other way and say, hey, I want you to run across all files that are not from Microsoft Corporation. I'm going to use that as my initial kind of delimiter. I'm going to drop in a limit of 100, as we saw before. And then my final searchers are going to be, what types of things would you like to look for? And the nice thing here is you can actually select multiple YARA hives if you want to. I'm going to pick Vault Typhoon. And the only thing I'm going to come back is I'm going to say, if you have a match, go ahead and tag that thing Vault Typhoon on the match. Let's walk through what this search is doing. I am going up to BinLib and I'm saying, BinLib, I want you to take the first 100 binaries that do not have a company name of Microsoft Corporation. And I want you to run these YARA rules against those particular binaries to see, do we have any hits? Folks, this is a retroactive hunt, a retroactive YARA scan that allows me to go through and look across my binaries for malicious information. I'm not going to name it publicly, but there is a very, very nice repository of files out there that allow for this exact same type of capability as well. I'm going to hop down into here. Let's go ahead and craft this YARA search scan one more time inside of here. And just a quick reminder for everyone, I'm going to hop here and I'm going to select Microsoft Corporation as my exclusion. So give me all the binaries that do not have Microsoft in the name, limit it to 100. We're going to select Volt Typhoon, and I'm going to add that tag on there as well if they get detected. Now, I hope we don't have any of this malware running inside of our environment, but nonetheless, I'm going to go ahead and kick off this YARA scan in the background just to see if it works. And luckily, we come back with no items were found, no matches were found, which is fantastic. And just in case you're curious and you're like, well, Matt, what did we search against? Guess what? I can actually go and repeat that particular search to show you exactly which files were captured. So I'm going to pick on company name again. We're going to select an exclusion and say, show me the files that do not have Microsoft as a company name. We're going to select the first 100. And there we go. Those are the files that we ran that YARA scan against. So the nice thing about the search parameter here is you can also go and kind of backtrack those searches and say, wait, without the YARA scan, what is it I went looking through? What are the things that I went searching through on here? And sure enough, we're able to populate that list as we need to. And there's actually some pretty good observations in here. There's some pretty good catches. A lot of Google LLC stuff. Looks like there's like, some forensic tools and things like that. But nonetheless, I'm able to utilize binary library to kind of narrow down a lot of those details. All right. Let me go ahead and kind of summarize everything we've been looking at here because we have a few minutes and I just want to take a look at the chats and see if anyone's got any questions or anything that's come up. And if anyone does have a question or anything they want to ask, feel free to drop it into the chat. I'm happy to go through and answer those as well. But BinLib or binary library is the collection of data and metadata pertaining to binaries that have been observed in an organization. If you turn this thing on, it's got to be done at a per org level. You have the ability to search through the data, the metadata, the hashes, tag, untag. You can also use YARA scanning to conduct searches across those binaries, giving you, in summary, as much flexibility from a searching perspective as you need. I want to look for everything from Google. Done. I want to look for everything not from Google. I want to look for everything that shows up with a signature date or signature details of a particular value. Show me everything that was not signed in the US or does not have a US signature associated with it. Show me everything that has a unique import hash. Let me take a malware report and run that data against my historical observation point here. Where this becomes super useful from a SOC monitoring perspective, from an IR perspective, or some other kind of feature set there is also going to be, let's say I'm working in an environment or I'm working for a customer and I've got BinLib turned on and they come to me 5, 6, 7 months down the road and say, hey, we just got this threat report from a trusted partner from an ISAC or somewhere else. Here's a list of hashes. Have these hashes ever been seen inside of our environment? Have they ever been observed? Have they ever been seen in there? Guess what? I can conduct and finish that search in about 3 seconds. Y'all saw me walk through it right here. Not only that, but as an analyst, as a security individual, I can expand that search a step further and say, hey, not only have those hashes not been seen, but I took that threat report, took a look at the metadata of those binaries, ran a YARA scan from that particular threat report, 0 hits. And I did all of that within the exact same console in the same place without needing to touch an endpoint, without needing to run some long detailed scan or some other type of intrusive thing. I can just quickly look through the binaries inside of an environment there. The last thing that I'll mention, don't forget, is that BinLib itself becomes an observable telemetry stream, which means not only can you look at the BinLib console or hit it via the API, you can also watch the events as they come through. And sure enough, there's the YARA scan that we ran a little bit earlier. So even the YARA scans that we run against BinLib become observable, and I can use those results in multiple different ways. All right, now I see that there has been a question that's come through in the chat that talks about if there is a cost associated with BinLib. The costs that'll be associated with it do depend on artifact ingestion. They also do rely on the reliable tasking extension, which itself is free. However, there will be some nominal costs associated with it that, again, as I mentioned, typically has to do with the artifact ingestion or the storage of artifacts inside of the environment there. However, BinLib itself is not is free to enable and free to turn on. You would just be looking at a cost for the artifacts or the data that's being stored. Now, of course, this is going to scale as much as you've scaled. If I turn BinLib on for 50,000 Windows endpoints, you better get ready. But that is why I talked about deduplication a little bit earlier on. We dedupe at the organizational level. So if I've got 10,000 Windows endpoints and the DLL is first seen all the way over here, and then I see it again all the way down here, I'm not going to be looking at ingesting that file twice. It's going to be automatically deduped and observed only once. And that, folks, is BinLib, binary library. What other questions do we have? I'm happy to take a look. Let me see. I've got the chat open here. Thanks to Chris and Andrew for bringing those questions up. Let me take a look at Slack and see if we've got anything popped up in here. Just got folks joining, which almost always makes me happy there. It's great to see. Well, if there's no other questions, I will happily give you all back a few more moments here. First off, let me just give a couple closing thoughts. Number one, thank you for joining me in the October Loud and Clear webinar. Hopefully everyone got a chance to learn something new about BinLib, or perhaps think about another way to approach some of the telemetry that you're collecting, number one. Number two, it's always useful for us to find out ways that folks might be utilizing these features. So we love being able to expand upon them and just demonstrate them whenever we can. And then the other nice part about this too is you learn about other types of features and capabilities, such as I mentioned, YARA scanning, which some folks might not be familiar with as a new way to detect malicious files inside of an environment. However, I'm going to save some of those details because in our office hours, our revamped office hours, I should say, this coming Friday, October 20th, we will have a little bit of a deeper dive into YARA capabilities. So with that said, everyone, that is our webinar for today. Huge thanks to everyone who's able to join us. Really appreciate it. And as always, if you have any questions about LimaCharlie whatsoever, don't hesitate to hit me up in the community Slack, or if you've got a Slack channel with us, feel free to jump in there and I'm happy to answer some of those questions as well. All right, everyone. With that said, thanks for joining me, and I'll see you again on the next Loud and Clear event. Thanks.